All right, chicken levels good. We're back. Welcome. Another week, more Haskell hacking. We're going to be working on LambdaTrek again, continuing on with our quest to explore strange new tiles and ways of programming, to seek out new state and all that stuff. So if this is your first time tuning in, welcome. How's it going? Nice to meet you. This is what the project looks like so far. I'm just going to pop over to my project file here, Lambda, or my directory, whatever you call it, you know, stuff. We use stack as our build tool here on this project. We're calling it LambdaTrek. This is like a Star Trek inspired roguelike type game. Inspired by lots of older versions of this sort of idea. That we are a little space captain of a spaceship here. We belong to some kind of organization that controls this area of space. It's currently being invaded by a bunch of other spaceships from another civilization of some kind. And they're here. And we gotta blow them all up. I know it's super violent, but it is what it is. But yeah, you go around, you do that. You do that by giving in your commands here. So we got like our information panel, the current sector we're in, the energy we have, and we have about 200 turns, at least for now. It's just like still in development here. And yeah, you can move around with like the move commands like that, you know. You can raise the shields up. We can move closer to that enemy ship. It's going to start firing on us. Thankfully, we got our shields up. It's going to reduce some of that damage, or a good deal of it. Yeah, we can't fire our own phasers, but maybe we can fire our torpedoes. We got a torpedoes command. Torpedo 8-3. Oh no, that was, what is that? Torpedoes. Something like that. I got the torpedoes command. I can't remember the name, what I typed it in as. And all that stuff. Right now, we're working on, we've been working on this quadrant map. This quadrant of space that we, you know, are in. These are our little sectors. Sectors we haven't scanned yet. Then we've scanned this one, because we're currently in it. The S means that's our ship. That's where we are. The dollar sign means there's at least one space station here, and that there's at least one enemy ship here. The idea, these aren't like literally next to each other. They're kind of like, you know, there's an abstract representation of the map, but we can go out and just explore others. We can use our long range sensor command to try and scan one before we jump to it. And so we scanned 1-1 here. We revealed that there's a space station here. So now we know there's no enemy ships. We can warp there. So our ship is moved over to 1-1 now. And if we pop over to our sector view, we can see there's our ship. There's the space station, the star, and all that sort of stuff. So the one thing we were working on last week, I think we're getting pretty far into and nearly done with, is implementing safe landing here in this sector. So we're just refactoring a little bit of the sector data and stuff like that. Trying to make sure that we always have a safe place to put the player when they are entering a sector here. So let's hop over the code. Take a look at how things are going there. Oh, I gotta bring up my editor, of course. I haven't done that yet. Silly me, not prepared. And yeah. Let's make sure I got chat here. Good, good. Poof. Okay. Here we are. Our little to-do file. Yeah, so we got to move the ship to a safe space, and then We wanted to do a little bit of refactoring around the sector because we have some invariants we added there while we were working on this. So let's hop over LambdaTrek. We're going to go into the simulation code and we're going to check out sector. Okay. Building sector tiles. Here we go. Right. I think we also need to remove the ship out of this too, if I'm not mistaken. Because the way we're going about this is that we want the sector to always guarantee that there's at least one empty space in it. All right, so we have to update set tile here. But not only to have that condition, like it should return nothing in the case where, you know, it's out of bounds, the X and Y is out of bounds, but also nothing when that tile just can't be set. So any case where you can't actually set that tile, we're just going to return nothing. So we have to update that and stuff in order to maintain that invariant so that when you go to build the sector tiles from the sector data, we can use that interface and do all that stuff. Thanks, Sean Vetter. I will try not to split my infinitives. No guarantees, though. So welcome back. Thanks for coming back and chilling with me on the stream here. Always a pleasure. Okay, so let's see. How do we want to go about this first? Oh yeah, because the other part of this was that we were going to add the ship to the sector. So yeah, let's break this mofo and yeah, get our builder running. We'll use the test runner as our builder. We'll go fast mode in file watcher. Okay. So removing a parameter, of course, is going to break a whole bunch of stuff. So we'll try and get back to compiling as quick as we can, even if it's not quite right. Because we're going to add the ship back in. Just a different way. So instead of unsafe set tile here, because we don't have a ship in scope anymore, we actually can use the empty sector tiles to build the star tiles. We'll do that here. Empty sector tiles. Yeah, we'll get rid of that binding. Yeah, now we're getting a bunch of build warnings that we don't use ship anymore. What's up with that? All these sorts of things. And let me just bring up my types. Type warnings. Yeah, we're going to bring ship back in, so I'm just going to comment it out for now, just to get rid of the warnings. Okay, so that's this module, but where we use build sector tiles is probably going to be, yeah, a bunch of warnings there in a couple places in the UI. I'm not sure if that's a bad Mojo situation. Why is it building it in the UI? I don't know. I think I have an idea though. Alright, so we build the sector tiles here, and then we just to render them. It's like render data. But we are removing the ship from this for the time being. We'll just add a little to-do. Add ship back in. Okay, that's this module. And there's probably maybe one or two more places. Spec, of course. Okay, mostly spec stuff. Okay, so let's jump over that. It's tests. Okay, build sector tiles. Now this test isn't going to be right anymore, I don't think. But we're back to compiling, which is good. Although we got a warning. That was line 38 or so. Yeah. What was that warning? Oh, defined but not used. Yeah. That's fine. That's fine. Okay, since we're back to building now, we're back to green. Okay, next step. Let's commit what we have so far into work in progress commit. We're going to say remove ship from build tile sector tiles. Okay, now going back to build sector tiles. So we've successfully removed the ship. Okay, so we use this fold function over the empty sector tiles to add each star, where we use unsafe set tile. We want build sector tiles to maintain our invariant here, that the built tiles have at least one empty tile in the set of tiles. And hopefully we can do that by guaranteeing that sector actually has all the, because sector tiles is really a projection from sector to like this tile structure that we use for rendering the view. The sector really has the data, so I think sector is really the one responsible here for maintaining that. But if we use these unsafe functions, they're obviously, it's going to be harder to maintain that guarantee there. So I think what we probably should do here is maybe see about using the safer functions to build sector tiles, or we can just trust that sector is built correctly. And just assume that it is. I like that approach because that means I don't have to change anything here. Even using unsafe. But I do have to trust the sector is built properly. So far, I don't think we use any of much set tile and get tile yet. Let's see. Find me a set tile, please. In the source code. Yeah, just the definition. And that's it. Yeah, that's all we've got. So that's fine, because we're basically constructing all the sectors ourselves by hand. Maybe what we could do here, just to make it a little... I want to know how often we're using this sector constructor directly, or if, I don't know if I want to bother going the whole route of internalizing the sector constructor and then making a safer API for this, but it's just good practice. Yeah, I don't know how much I'm going to use it. How much do I use the constructor? Over at ML, it makes sector an abstract type. Yeah, like we could do something because like let's just do it because we're just learning here. We're having fun, and maybe this is a pattern that would be useful to see for folks. I'm not sure how often I'm using the sector constructor directly to build these things, but one pattern that's sometimes used in Haskell code when you want to make certain that your data types are correct by construction, like you can't build them wrong, is like using a smart constructor. Right, it's just a basic pattern, like another name for a function that builds your record for you, and then you're supposed to like use the module export list, just not export the constructor function. I don't like that necessarily because the constructor functions are useful for like pattern matching and things like that. Yeah, so shown fader, you know, is generally that's a good thing to do. Yes, I would agree. I would say just go for it anyway. So you don't have to worry about it, because sometimes you shoot yourself in the foot when you think, I'm too smart for this. I can manage my data just fine, and then you're like spending hours debugging things that are silly and not worth your time that you could have prevented. So let's go ahead and do that. So what I'm going to do is I'm going to make a sector director here, and I'm going to make an internal module. This is the pattern I like to use the most so far. I've seen a lot of different patterns and like naming conventions for this sort of thing. But the idea is you have this internal module, types module, something like that, where you put your types, like sector. You import that here in the main module. Actually, I'm going to get the whole thing with the comment and everything. And then you control the export list on the main module. This is the general gist of it. I need that. And that way, at least if I do need access to the constructor directly for whatever reason, as I change my code, I have it. I can just import it from the internal module. That means I don't need template Haskell here, but I do need it here. And that. And station. And then what do we got? Oh yeah. That's just a bunch of extensions we needed. We probably don't need here anymore. Yeah. That. And let's see. Oh yeah, I can just remove this. Okay, and now I can just import that internally. LambdaTrek simulation dot sector dot internal. Quadrant needs to change that, all that stuff up. So then we just re-export that internal module here. Now we're gonna have to, in order to do this, we have to like futz with export lists. Another one of those things that some people will say is like, good thing to do is to have like explicit export lists. Okay. You know, I find it's a bit busy work. It's not my favorite part of Haskell, which is why I try not to use them, but sometimes you just can't get away from it. So we're going to export the sector like that with its without its constructor. Sorry. Right, and then we'll export from here a smart constructor function for building sectors. That will know all about that. So I'm just using some Haddock markup here. In comments, you can use this little markup language called Haddocks that kind of generates nice documentation from your code. Sort of like a lot of languages have this kind of tooling. Haskell has it too. The reason why I don't like this stuff is because like it's just super tedious to maintain. It does have a benefit, so sometimes it can be pretty useful. Oh yeah, we'll need excuse me, just getting some water here. I forgot these set tiles and get tiles are working on sector tiles, so we'll need a safe interface as well for sector. Maybe we won't need this for sector tiles. Sector tiles is just something you have to derive from a sector. Yeah. That's probably better as an API. Okay, I don't use it, so let's get rid of it for now. Okay. Any hoozle. Let's see. Empty sector is fine. We got more things to export here. Bind empty. Build sector tiles. What else? Render. Live enemies. Enemy accord. The nice thing about doing export lists, though, like this, explicitly with the Haddocks and stuff, is that when you generate those Haddocks, it gives you a nice API documentation for the module. And then you can hide implementation details using that internal module. And provide a nice API here. Okay, so we don't need those. So export list works. So let's get back to fixing quadrant. Try and get back to green again. Sorry, quadrant. Here. Sector is not in scope. Okay, we do use the sector constructor here directly, do we? We import the type here. Yeah, we do use it here. We use it there in the record wildcards pattern match. Which I think that's why we're going to want the internal module for stuff like that. I think... Yeah, I think we do need to import the constructor in order to use that. Yeah. Okay, so we're going to import the internal module here just to get us to compile again. And then we're going to replace that. Looks like we don't need both, at least. Let's see, combat. Yeah, so we moved the lenses that are generated. So we need to re-export the lenses as well. Sector enemies? Or enemy ships? Thing there. Okay, and that's just in the test code. So that's going to be a pretty easy fix for this test code. Just import from the internal module. Or, no, it's this constructor, yeah, so it needs to import that internal one. And then just a normal little warning in the spec file, that's fine. Okay, we're back to green again. Good, good. Let's make a little work in progress commit for this. Just add an internal module and move the type inside there. And the constructor. Yep, sorry, all staged, ready to go, work in progress. Move sector, type, and constructor. And the next step is to now add our smart constructor and export that. And then all of our code that imports this module can use that in order to create constructors or the empty sector constructor, as is the case may be. And then we can start making like a nicer API around sectors. Another nice bonus of this pattern too, of course, if you don't know, is that now that it's internal, as long as we provide a nice consistent API to work with sectors, we can change that internal representation. Like maybe we want to get rid of arrays and use something a little bit more flexible. We can do that, right? And then nobody has to be worried about us changing that and making that decision. Well, maybe they won't have to, but the thing is, when you're making a game like this in Haskell code, you're not really making an API for, unless you're working a large team, anybody else. So how far you want to go down this route is really up to you. What you find useful and convenient and helps you get your game done, get your project done, get things rolling, you know? Okay, so sector. Okay. So what do we need to construct a sector? We need some enemies, stations, potentially some stars to put in it. Let's see. A list of coordinates for the stars. What else? Enemy ships. We could do a similar thing. Except... Yeah. We're gonna have to set this up so that it indexes properly the way we want in. So we might actually do want some kind of API in there. What we could do, enemies have positions. So I think we could just do a list of enemies. And a list of stations. I think stations have their position information in them as well. And we should be able to build a sector. And then, because this is a smart constructor, there's going to be some kind of information about, like, you know, or maybe you don't. Some kind of, something can go wrong, and we want some way to indicate that. You know, you didn't provide us the right data. We can't construct that, sorry. I'm going to leave it as string for now. Maybe we want a better type for that. Okay, cool. Let's bring all those in scope. Let's see here. So, when creating the smart constructor, you might say, like, oh, well, you know, we know that we only want a certain number of stations. Shouldn't we use a sized type here and make the caller give us the right? You can go, keep going and going and going and going with this sort of, like, correctness by construction type stuff. I think smart constructors should be, like, they can be annoying to use, so I try not to use it too much because of this either type that gets stuck in there, or like maybe or something like that. But you kind of have to at some point like raise your hands a little bit and go, I don't. All right, and so the buck is going to stop here, basically. A list implies that you can give you like 10,000 enemies. Right. Doesn't mean I'm going to use them all, though. Same with stations and such. So you might give me a really huge list, but I'm only ever going to take so many from it. And then the other thing is, like, those enemies better have valid positions, so that's another thing that can go wrong. And then our other invariant is that, yes, we have to have at least one empty space in the sector available at all times. And that should also fail. Alright, so we could probably document a little bit about that here. A valid sector. A valid sector is, a valid sector has at least one empty space at all times. So that we have somewhere to put the player ship when they warp to the sector. And they warp it. That's okie doke. Super good. All right. So, the design of our sector is 15 by 15, I believe. All right. 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. Sorry, 14 by 14. 10, 11, 12, 13, 14. 14 by 14. Okay. Whatever size it is. It's fixed, though. And it's all the same. So 14 by 14 grid. So that means we know that we can have a maximum of the total sum of this list, and this list. The lengths, right, of them all can not exceed, what was it, 14 times 14 minus 1. That's the gist of it, and that's how we can guarantee that. We can also take up to 14 by 14 minus 1 of each from these lists, because you could imagine like some weird cases where I'm like, I want to fill it with stars. And that Should be fine as long as the other two lists are empty. And that would satisfy our other equation. And that would be it. I think that would do. Okay. We can go to our spec here. Pew, 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 pew. Test spec. Just make a couple of quick examples for ourselves. We already have sector with find empty. That's great. Inner. Let's get rid of that. Let's add sector. Given a nearly full list of stars. Given it's all stars. Let's have a little fun there. There we go. Still makes sense. So it's all good. I'm gonna know what this means here. Right? In the future? Okay, given it's all stars, it should construct a sector with at least one empty space. Okay. So we're just gonna... Oh, there's some other weird cases. Like, what if this list is just all 0, 0? Right? Not technically full. Yeah. Yeah. Let's just do our good old full sector. We'll borrow this constructor here. And we'll just remove this. Okay, so this list here of coordinates would fill up the entire space. Right? Every single star. Okay. And given that, we should say that sector well, we want the invariant maintained here, so that it has at least one. And we will give that the sector with stars and the empty lists for enemies and stations. So we have to define has at least one empty space. All right, that's got to take a ship. A bool, I think. Or not a ship, a sector. No. Okay, so how do we know a sector has at least one empty space? That's a good point, Sean Fader. All right, we could implement it both ways. We could implement it. We could return it as an error, or we could just drop a space. But then you have to ask, well, what space are you going to drop? And as the caller, I might not agree that that's the space you should have dropped, or the space I wanted you to drop. You probably should have just told me that my data's bad. So I would err on the left in this case, I think. Unless it was just made super clear, you know, it's not bad, it's not wrong. You can just make that super clear in the documentation. And just say like, okay, if you give me a full space, a sector full of stars, we have to maintain this invariant, and so I'll if you give me more stars than I can, I'll give you back a sector without returning an error. It'll just have the one at 0, 0 empty to maintain that invariant. And that's something we could just decide and just say like, yeah, that's fine. It's not wrong, it's just convention, you know? I think returning an error is a bit pedantic, but that could be the right kind of pedantic. Personally, that's what I like. I don't like things. I don't like software that tries to, or libraries, or things that try to like think what would I want. You know, the other thing you can do with the smart constructors, with maintaining that invariant, is that you could say, you could pass that as an argument. Which space, if I find it's completely full up in here, which space do you want to be the empty one? You can pass that as an argument, or you can make a separate constructor to do that as well, if you want the caller to define that instead of returning an error. And that might even be able to remove a bit of few cases from your either as well. That function. Okay, so has at least one empty space means we need to be able to iterate over all of those coordinates that are in our sector representation, get the data out of the sector, and in a list. And as long as that list is shorter than 14 times 14, then we're good. Which means, like, in the worst case, we're gonna have to look at 14 times 14 items. Or I'm thinking every case. That's a linear one. But I don't think that's a terribly big problem for this code. It's pretty small. So yeah, that seems fine. Yeah, so let's get the sector. Okay, so then we have to sector objects, maybe? We need some way of getting a thing at that coordinate in sector. Or just iterating over a sector. That would actually be pretty simple as well. If there was a function that was just a list. What is going to be a list of, though? Because we have different types in there. We have just coordinates for the stars, because we don't have any data for them. Enemies and stations. We could make sectors foldable. And then a retrieval function that gets an item at a coordinate. And if that returns something. But then again, we have the same problem where get is going to return different things. Enemies, stations, coordinates. So we could hide that and make it a Boolean. Is something there? Yeah, because arrays are going to be fixed size. What other way? We could get the number of stars out of the list. We could get the number of alive enemies out of the enemy array, and the number of stations. Yeah. And it's just a simple calculation. Is that less than 40 by 40 minus 1? Yeah, okay. Let's go that route. So, num stars. We'll just assume that's the length of sector stars. Num enemies. Sector enemies. And num stations. And we have the sum of num stars plus num enemies plus num stations is less than or equal to 14 minus 14 minus 1. And then our invariant is maintained. Has at least one empty space. Now that probably isn't going to compile because that's a little bit of wishful thinking in that code. It's only complaining about the hole right now in sector for our implementation though. So that error might come back and bother us later once we actually implement that, because it's probably just trying to compile our modules first before it's compiling the test module and encountering errors there. So constructing the sector then, let's try and just return the simplest thing we return that does nothing useful. Okay, we don't have record wildcards in the test module. Let's go. Yeah, okay. There we go. Yes, yes, okay. So sector should be in scope. Oh, because I didn't add it to the export list. This is why the export list is annoyed the shit out of me. Pardon my swear. Although, I don't know if that's actually a swear these days, but I try not to say it. And then I just did. La la la. Sector. Then the other thing that's going to annoy me is that I'm going to want to keep this alphabetically sorted. And yeah. And yeah. And yeah. And yeah. Although I'm going to move sector up here and make that a smart constructor section. Or constructors. Okay. Okay. Right. Okay. Yeah. Has at least one empty space. So Let's write this a little bit differently. A sector stars like this should satisfy has at least one empty space. And that needs to be a different type. Match our constructor result. So string. So this is going to be a right sector, and then our pattern match for the left case would be false automatically, right? It's trivial. Okay, and now sector enemies not in scope. Yeah. So this is the wishful thinking code here. So we have the lens that gets the sector enemy ships, the sector stations. We should have maybe... that's going to be named after the... fields generated by this make field stuff is generating an accessor called enemy ships there function. So let's call it let's ships instead, maybe. We can get a list of the enemies. And we got list stations, sector, list of station. Make it do something dumb and useless for now. And list stars. And that's just going to be the positions of the stars, I guess, because that's all the data that we have. And that's trivial to write, so I'm just going to write that here. There's just sector stars. And then we have to add it here. List enemies. List stars. List stations. Oh, what did I call it? List ships. Ah, that's silly. I should have called list enemies. That's what I meant. Okay. And so those are good. We can go back over to the spec now and change that up. The stars. We'll give this a name. Oh, no, we can just pull it into sector. We don't need the record wildcard anymore for it. Sector. In fact, I'm not going to use that. I'm just going to use the dollar there. And there we go. Here. Boom. Save ourselves a little punctuation. see how that's turning out there. We have list enemies, list stations. We're not using the lenses per se here. We're using these accessor functions, which means we can change the types underlying these later on. Where I guess the lenses are really convenient. I quite like them. I mean, if we change the underlying representation, like, callers are going to be, you know, we might be concerned about that, depending on how they're using the data. But this is like learning code. We're hacking. We're figuring things out. Right. Okay, so it's compiling. We're getting left to our trivial case here. We're not really doing anything, but we're getting like in the right ballpark. Okay. So at least now our test code can work. We know that we can do that. So let's go back over to the sector code now, and back to the constructor. And let's see here. How do we want to write this? We want to get the number of stars. This function is actually pretty useful. We could probably make that internal to our module. Just construct this thing. Yeah, that's what I was thinking, Sean Fighter. Just use this predicate. Construct this. Maybe we'll put it in the internal module. And it's documented right next to the data structure, which is nice. Which means we probably move those accessor, or those kind of like helper functions as well. Here, otherwise we get circular imports. Record wildcards? Yeah. That's Haskell case there. Boom, boom. Okay. And so, yeah, then we should be able to just construct this station, use the internal constructor, check if it's valid. At least for this property. And I think that's it. We might want to just do this like that. Stars. We have to convert the input list of enemies to the array representation. And we can do that there like this with enemies. And we could write maybe 2 station array stations. And it's okay for our smart constructor to know internal details about like how sector, like what data structures are here and stuff. Because it'll still protect callers from knowing that. And then, let's see. And then we just check. It has at least one empty space. Although we don't need the right on here anymore. We could just do sector. Then right sector. Else left invalid sector. Doesn't tell us much at the moment. We can make that better. Let's get this to work. Let's add. So we have a list of enemies. We have to convert them to an array of int enemy. And we need a 2-station array. So station to array int station. And we'll leave that undefined for a moment as well, just to get everything squared away. Sector. Right, so we want to change this to sector here. Peel that off, and then we don't need this case. And then our test code. Should satisfy is right. We got that from data either already, so that should be good. Oh, that should be is left. That's right. So this is this test case. We're filling it up completely. So we already passed our first test. Haha. Okay. Context. Given just enough stars. It should construct sector. I'm gonna pop this here once, maybe with our little one space empty condition. That should satisfy is right. Ooh, what do we get here? Probably left. Okay. Well, that's unexpected. Maybe because we haven't actually done anything yet. Catch up, man. I've kind of expected to get to the undefined, actually. Mm-hmm. I think that's probably what's going on there, so let's just go implement that quickly. All right, So to create the array, we need to have our set function to convert from the enemy position to an array index, which we do a fair bit here. Oh, we should maybe have a function for generating that index. Actually, what do we do with enemies on that array? Empty sector. Oh, we just use the enemy. The enemy has its own position in there, so we don't actually have to do that. Yeah, so this array thing is really not used. It's kind of not good. Okay, so if we do want to construct this, then we can just to enemy array is going to be as a zip. I'm going to use arrays constructor function there from data.array. Not from list, it's array list array. So as long as we can calculate the bounds from the list, the input list, we should be able to do that. Length of these. And zero length of ease minus one. And ease. S's, stations, same thing. If it's not inclusive, I think it's inclusive on the bounds there, if I'm not mistaken. So that, I expected that one to pass now. Okay, let's change that to S. No problem here. It's shadowing the names of the lens accessors. That's right. Okay, we want to re-export those, so I like that. Yeah, maybe. Thanks, you Sean Plata. I think you're alright, maybe. It does. It should not construct. Sector. Yeah, backseat comments are totally welcome on the stream. I should probably make that clear in the stream description. I like it. I'm totally down for backseat comments. Yeah, I don't really care about that. Wait, not all stars. And this one should be all stars. Yep, yep. Okay, so internally here, let's make that stars. Stations. I'll re-export the lenses for now, because they can be handy sometimes. Oops, I accidentally went too far with the match. There we go. Services. Fail. Okay. Yeah. Okay. We still have to figure out why that is. Okie dokie. It's probably our implementation has at least one empty space, I imagine. No problem. Qualify. Let's do just a little bit of debugging to print out what we're actually getting here. It might just be this value here that we're comparing against. And we're going to debug.trace here. And we'll build up non-stars. Enemies. These and num stations, just for completion. And oops, post-positive position again. Of course, we use post-positive position on my work code I use at work, and I always get them messed up when I go back to doing open source libraries or work on the stream. As debug, there we go. That kind of silliness just happens. Okay. Enemies 0, 0, numstars 224. And then 225. So that should be fine. Right? No. 196. Yep, we're completely off base. Yeah, we're way out there. That doesn't seem right. Maybe that's, yeah, we're just a little off here. Survey says we were off. Yes. 15 by 15 elements. Yes. Da-da-da-da. Brain fart. Psh. There we go. Yep. Okay. Get rid of that. Brilliant. Pick her up, pick her up. Pick her up, pick her up. Oh, thanks, Sean Fader. Yes, it's good to be kind to yourself and realize that programming is hard and little mistakes are really easy. Yeah. Okay. There we go. And this is actually one of the reasons why I really like, or have really learned to like, programming in Haskell quite a bit. It took me a long time, actually, to like learn it and get into it and be productive in it. I think that's pretty normal from what I've seen. And, you know, a lot of people fall off the cliff of it, but... and you can do this in any programming language, right? Like, if you do test-driven development, that kind of thing, you can really keep yourself honest and stuff, but... it just goes a little bit extra with Haskell sometimes, you know? Especially when you're like, I don't really know 100% what I'm doing. You can really lean on it quite a bit to try and like logic it out and then have it fetch things for you if you're clever about it. Well, you don't have to be overly clever, but I mean like if you think about things a little bit. Okay. Anyways, I hope that made sense. Ramble. All right, so that's good. I think we got one more, some examples and some other examples I want to make sure work. Is that if we have, you know, almost all stars in one enemy. Given almost all stars and one enemy, it should not construct sector. Alright, so we're going to take the not all stars from our previous example. And we'll make one enemy. Any enemy will do. We can just find an example one that we probably made in here somewhere. Yeah, here we go. And if we use this, we should get an error as well. So we go sector, not all stars, one enemy. That should satisfy his left. And that will pass, I think. If it compiles. Oh. Ooh, it does not. Okay. And that doesn't because this. Yeah. Okay. No problem. Let's fix that. So we're just going to get the sector data. The moment we're going to do something with the sector enemy ships. We're going to use data.array to get the just the values, the elements, I think. We might as well go do the same thing for stations while we're here. Stations. That'll do it. Yeah. Okay, that's pretty good. Pretty good. Let's just do one more and make sure that we're just testing the edge case with at least one station. Oxford comma. Not sure if that's the actual. The Oxford comma is like where you put it in before the final conjunction, right? Let's see. We'll borrow not all stars again, but we'll leave space for. We'll do 13 and what? It doesn't really matter the positions here. Nice. Good, good. I'm right about the Oxford comma. Ah! Education wasn't a waste on me. Alright. We're going to jump over here, grab an enemy. And pop it here and get... Just line it all up. Do similar things for station. And then we should be able to do sector, not all stars. One enemy though, one station. That should satisfy. It's left. And shoot, do I have a station that I constructed in here? An example station. No. Station, pretty simple to construct. It doesn't matter where we put it for now. It might matter later. Oh, I forgot to make it an it. Inside my context. Yeah, we'll just pop you. Where, what did I do? Go here. To go. It's also called a serial comma. Is that American? It's weird. Maybe no less valid though. A rose by any other name. Still a rose. Okay. Yeah. Let's see if that passed. Oh, no, because it couldn't compile because station is not in here. Simulation station. We're going to import the qualified, I guess. And skadoosh. That should be good. Yes. Okay, and then like a good happy one. Let's see, context. Given enough space for everyone. Could construct a sector. I'll do not all stars again. We'll leave one empty spot in there. We'll grab an example enemy. We'll throw an enemy in there. But oh, I'll leave two holes in the stars there. Again, it doesn't really matter which ones for now. We wanted to improve this API a little bit, I think. We should also consider what the constructor would do with things in identical positions, because they each define their own position. All right now, and we're kind of assuming that they are all the positions are unique by this this formula that we have so far. Now our constructor can also test for that case as well, and maybe it should. But let's just get these working. Oh yeah, I gotta put my assumption in there. Almost done. Should satisfy is right. Okay. Not. There we go. Okay. Beautiful. Beautiful. It's gonna go green. It's gonna go green. Yeah. That's what we want. Okay, so let's consider that case now. Right, where we make enough stars to fill the whole thing, but they're all at 0, 0. What should happen? Should we construct this and consider this a valid sector? Should we deduplicate all of those stars? That means we have to go through the whole list. In either case, I think. In every case. So we might also want to make sure that we don't consider more elements than we need to, because lists can be infinitely long, right? So that should be another thing. So these are all the edge cases to it. But the bonus with it, with smart constructors then, is that once this is all done, the rest of your code doesn't have to worry about is it valid or not. It just is, by virtue of being. And that's lovely. It's a nice thing to have. It's a bit of work to get there, but it's nice to have. Okie dokie. Let's go. Given all of the stars are at the same location. What should it do? I think it should deduplicate. Although that might be the right kind of... No. We wanted to be pedantic with the API a little bit here. Maybe we should just stop constructing as soon as we detect a duplicate star location in the list. Or we can make the API a little better. We can improve the API of the function itself. That might be something we could do. Yeah, like we can have the logic of the constructor pick up and enforce this invariant, that all of the star locations have to be unique. All of the enemy positions have to be unique. And all of the station positions have to be unique. Alright. And then we can get into overlaps between those three sets. And that actually might lead us to a better design for our invariant. I'm thinking a few steps ahead here, but I think that might be the way it goes. Yeah, exactly. Because when we go to construct the tiles, we don't have any concept of overlapping tiles. We can only represent in the game due to the way our UI works. And we've decided this is, by the way, just pure convention. We decided that it's just going to be one tile, right? There are ways in ASCII-based games to like have tiles that stack over top of each other. And then the ship would be able to occupy the same space as that thing. Which I think actually, now that I think about it, we kind of do sort of in the game. Although I totally messed up this a little bit. Because we removed the ship from the tile so you can't see it. But I think the player's ship can move into a destroyed ship's place. And the player can enter that space as long as it's destroyed. But our collision detection won't let them move into an enemy ship here or here. It's not technically stacked when it's destroyed. And just that's another edge case we probably want to think about too. I'm going to add to the to-do list. Destroyed enemy ships probably shouldn't count for this as well, because the ship can go over top of them in our simulation. Make sure destroyed enemy ships count as a safe space. Yeah, the destroyed enemy ship, it counts as a safe space. It's fine. It's cool here. The enemy is gone. But we need to do, yeah, I think we should count that. Or not count them at all, basically. Anyway, back to sector now. So the constructor here, this is list. List says nothing about the uniqueness of these things, but there is a data structure that does. It's a set. And so there's two approaches we can do here. We could have our constructor function just take a list because it's convenient for the programmer and the caller, and for us to just pass a list. Right? Or we can push the responsibility on the caller to provide us the proper data and the right structure. And at least sets are pretty easy to construct with that invariant that they must be unique elements there. Would that get kind of annoying to use this sector function? Yeah. Are we going to be constructing a lot of sectors? Don't know. So I think what we could do for now is just do that conversion ourselves here internally. And do the logic way instead of doing it the type way. So at the term level, we can validate the list of stars. Okay, so what are we going to do about that? We're going to go valid stars. And we'll replace stars prime here with valid stars. And we could, let's see, we're only going to take like a maximum number of stars. That's 15 times 15. I'll just write it in line for now, just because I'm thinking about it. I don't want to get distracted. Stars prime. Okay. And now we have a fairly inefficient way of considering a list as a set, or converting it to a set in Haskell from the data.list. I think it's not very efficient, so I don't recommend using it most of the time. Just use an actual set. I'm leaning, so my fingers are off the home row here. Data.list. Pop-up. I believe it's called, well, there's nub. Super bad. Right, and that's why it's bad. Okay, is ON square on 15 value, like a list that's 15 times 15, that bad? Probably not. But that's why I'm like, try to take that into consideration when you're using nub. Don't use it on production code where you have like unbounded inputs or you expect really large inputs. Alright, so we take only the first 15, only the first so many elements, we nub it, and we make those the valid stars. If that is less than, the valid stars' length is less than the input stars, then 15 times 15 minus 1, sorry. Alright, so if after nubbing it, it is less than the input length, then we know we have duplicates in there, and we can throw our error. Cool beans. Yeah, no good reasons. No good reasons, Sean Fader. I think I had some ideas at first about how to structure the data for the game. And now I'm not so sure that I want it to be that way. I think stars, I was just starting out with lists, and then I was like, oh, maybe we should... These are going to be fixed size all the time, and they're not going to change, and we could just have static arrays and just allocate everything up front, and then we just have flags to turn things on and off. And I'm still not I'm like kind of on the fence about if that's a good approach for sectors here. I think I will know more, but I'll have a more definitive opinion about it once we get into the procedural generation part. I have a feeling that arrays might turn out to be a good thing in the end. It just might take a bit of work to get there. Just because, like, with the way the procedural generation algorithm might end up working, it might just work better with indices. Just being able to set flags without it being too complicated. Right. Like I can imagine the constructor just constructing just a big array of enemies, but none of them are active to begin with. Right. And then the procedural generation could proceed through the array and just say, okay, well, pick this one, and this one, and make them active. That kind of thing. And then, yeah. It depends. There's different approaches to it, too. So, but the nice thing I think about this pattern and what we're doing here, even though like I started off with the learning thing to show people how to do smart constructors and how to design modules to use smart constructors and make them still kind of ergonomic and all that stuff, is, as I was kind of mentioning as I've been rambling, that hiding implementation details is pretty nice, because when you're not super sure about how you want to go with things, you can change your mind later. Right? As long as we keep hiding the fact that we're using arrays underneath or lists or whatever it is. And as long as our calling code is using the API that we define at the top level module, we can change our mind about those things later on without having to touch too much of our code. Okay, so yeah, we take the nub of the valid stars, and then our next step here is compare that to the length of the input stars. Or we take the input stars and we take the nub in the second step, second pass. This, and then I don't have to potentially take the length of an extremely long list. We could at least break out this other case in checking first if the input stars are, the valid stars is less than input stars. Is equal to, is less than valid stars. We're starting to get a little creep, but don't worry about it yet. We can flatten this back out. Let's see. Oh, length of valid stars, sorry. Okay, and this should be duplicate stars, maybe. We'll clean up error reporting at a different stage. Okay, so given all the stars are at the same location, it should not construct a sector. It's called bad all stars. Right, and this will just be always 0, 0. And yeah, then if we go sector, that all stars, empty list, it should. Well, we want to just satisfies left. Should be duplicate stars. Ooh, I was kind of expecting that to pass. Wait, given almost all stars in one enemy. Given all the stars at the same location. Oops. Oh, sorry, I gotta dedent these. So the context is buried at the wrong indentation. Wrong these. Did I just make it worse? I did. I don't know how to even dedent. I almost never. I'm just gonna do it this cheapy weird way with rectangle. Here. There. Okay. So do. Two failures. Okay, this one, given its all stars, should not construct a sector. This needs to be flipped around. Okay. So our test passed for that, but we broke a different one. So given its all stars, should not construct a sector. Okay, so because the input stars, we take this many from it. It's always going to be valid. That's what it's saying. We introduced a little bit too much correctness here. Or, maybe not that. No, more like, if we only take the exact amount, it's always going to trivially be true that if you give me too much data, it doesn't matter. I'm always going to be able to construct it properly. Which could be good. Could be good. I think that's okay. Yeah. You know what? I think that's good. I think I'm changing my mind about this. If we only take the limit, the other things will still hold true about the constructing the thing. It's just that we only consider all the stars. So that particular test case is made useless by that. And I think I'm okay with that. We'll take that off the list. So the other cases still hold, though. So if you have enough stars and you put a ship in there, it's going to be, yeah. And everything will still be true about the sector. We should just document that. Only takes maximum number of stars considered. I'll mark that up. That is 224. And they must be unique in position. They must be unique. Actually, the maximum number of stars, enemies, and stations. It must be unique in position. Yeah. We'll do the same for that as well. Okay, we are running a little low on time, but just do up the next little bit of this. Okay, so now we know that we check the validity of the stars, and they're all unique, and there's only so many of them. The maximum number of them we'll consider as the valid limit. And then we can do the same thing for enemies and stations. And then we'll do 2 enemy array nub input enemies. Nope, we'll do the nub here. We'll do the check before bothering even constructing that array. We'll take the input stations and valid stations. Okay. So we got those. Then we have the input enemies greater than the length of valid enemies. And we're going to need a nub by on those because they have their position internally. And that's true. And then left enemy at duplicate position. Else. And if input stations greater than length of valid stations. And then left station at duplicate position. Else. Oh yeah, look at that. Oh, stacking them together. Okay, we need nub and nub by to import. Nub by is the version of nub that just takes the function. And we can nub by the position of the enemy. I wonder if we had a generic way to get positions of things that are positionable. I thought I had implemented that class. I did. I did. Okay, good. So we can just plop has position in there. Or get position, sorry. And get position. Oh, it's not in scope, is it? I don't know that we can import that here. Hopefully we can. That's going to be an import cycle. Let's split it out into a module. Oh, this is turning into a big step. I don't like big steps, but we're almost there. Let's just keep going and plow through. Okay, we're going to call it position. No. Kill it. Yeah. We will call LambdaTrek simulation position. And simulation position. And we'll just put that class in it. Yeah, maybe this instance. Pretty generic. Yeah. Yeah. Okay. Then I'm going to move this instance definition next to, well, this, yeah, next to the enemy. And ship. That for ship as well. Plop it right there. Not that one. That one. Okay, and then what are my problems? Okay, yeah, flexible instances. Don't need that here, but I do need it in the position module. Or maybe I do need flexible instances. I don't know. You'll tell me, GHC, though, won't you? You will. You will totally tell me. Okay, we need record wildcards and ship. Apparently. So we'll define that here. Language, record, wild cards, baby. And there we go. And the survey says, cool. Not in scope, but it will be soon. LambdaTrek simulation position. There. Then okay. Could match type end with enemy rule. Okay, not quite get position the function I put in nub by there. Okay, yep, no problem. Fix that. Go here. Adaable. Okay. Yeah. Yes. So this will be like enemy 1, enemy X, enemy Y, and get position EX is equal to like get position EY. Not the best way to write it, but it's just the most straightforward way. Maybe, no, I shouldn't say the best way. I mean the most clever way. But that's fine, you know. Let's just get some here. SY, or SX and SY. At least it gets the point across. Okay, and the next problem here, of course, is boom, right here, variable not in scope S. Has at least one empty space. because we took out S, we have to construct that again. So once we've got all of the valid, excuse me, data, we need that S against scope again. Yeah. Valid stars. We need still the 2 enemy array, valid enemies, and 2 station array, valid stations. And then pump those over. What's from this one? Oh, not station, sector, bar. Okay, oh, station doesn't have position. Well, it should. Let's go to find one now. Get that, get that. Position. Let's put that up here. Station position X and station position Y. And we need record wildcards again, don't we? Record wildcards. There we go. Okay, GHC, tell me, what do we got now? Okay, some more missing imports in simulation. We have to bring position back in scope here. Okay, cool. Oh, we're back. Sweet. Given all the stars at the same location. Should not construct a sector. Good, good. Yes, yes, yes. All right, that was a big one. Let's get it all in. I think we're going to end up squashing this all down into one big super commit anyway. Okay, cool. So now we added position checking, overlap checking. Which I think knocks out that to-do item. Oh no, not destroyed ships, but at least duplicate spaces. This here is kind of sort of what we're working on here. We just need the setters. But we have just added the smart constructor. Okay, I think there's only like one more thing maybe for the smart constructor to do, which... yeah. I'm going to consider that mostly done. Yeah. For now. As we need more from it, we'll just expand the spec out for it, and that's basically how you do that. Okay. So let's rebase and squash this all down into something minimal. Reword that. Bam, bam. And we're going to call this, when applied, this change will add a smart constructor to sector. To internal module. And smart constructor checks. There's at least one empty space. No duplicate stars, ships, stars, enemies, or stations. Boom. Boom. Okay. Nice little chunk of work there. Yeah, there's a couple of different ways, but like that's a pretty common one, I would say. And my favorite way of doing it for now. I've seen a few different ones. Some people, when they write those modules, they won't use an internal module. They'll just not export the constructor from the export list. That's not my favorite, because sometimes you do need access to that constructor. And so like I'm always like, expose your internals to me when I actually need them. I don't mind importing them from an internal module, and it even makes my code a little bit better, because then I know I'm importing from an internal module, and people can be like, hey, are you sure you should be relying on those internal details in code review and that sort of thing. You could be like, well, yes, actually this is justified, so please merge. That sort of thing. Okay, so let's push this up. All the code for this project is on GitHub. In fact, I've already got it pulled up. I don't need a new tab here. Boom, at LambdaTrek. All right, there's our smart constructor to sector. So next time we work on this project, we will now be able to finish up our work on find empty. Now find empty can trust that the invariant is held, and that'll be good. And then we can proceed with more gameplay code. Maybe I'm thinking the next stage of this project will probably start getting into, after we get that done, the procedural generation, and start generating a quadrant for us to work in, to play with, and start playing with mechanics. And then I think that's enough skeleton that if we wanted to take this game further and kind of add our own flavor to it, we've got enough of the basic formula from that original like LambdaTrek game that I think we can diverge from here and make something interesting if we wanted to go that route. Or who knows, maybe we'll do a new project. There's a new year coming up, you know. But I will be streaming next week, speaking of holidays and stuff. The week after that, I think I will probably be taking the rest of the month off. So next week, I always kind of wanted to start doing this once a month open source support type stream where we work on just working on some Haskell libraries and contributing back to the community, and showing people, you know, how to on-ramp onto Haskell projects if they want to start becoming a contributor. You've learned enough Haskell, you're ready to take to the next level, and you want to help out the community yourself. And so I think we might do that next week, or maybe we'll keep working on LambdaTrek. But let me know. You can let me know what you would like to see next week. Leave your opinion. I'm on the Mastodon, on the Fediverse. I'm on the types.pl server. I'm Agent Ultra. It's been a pleasure. And you can shoot me there, or if you go to the link above me, there's a Discord server there, and there's a channel on that Discord server for this stream where you can chat with me between streams whenever you want, share your projects, your ideas, ask those questions you didn't want to ask on stream, whatever. Or if you're in a different time zone, you couldn't be here. It's all good. So you can ask them there and let me know there what you want to see next week as well. So thanks again for tuning in and watching and hanging out. Thank you, Sean Fader, for being an awesome backseat programmer and getting involved with the project. And yeah, let's see if we can find... There's not a huge amount of us, but we could do a small raid. See if we can find someone to jump in on. You know what I mean? Let's see. None of my followed channels are online, so I'm not sure who's going here. Categories, software and game development. Let's look. Sleep detection with deep learning. Ooh. Advent of code. Chrissy codes. Also DNS server, maybe? Could be good. I like vibes. Let's do it. Boom. Let's start this raid.
Is it opening my terminal inside Vim?
I'm gonna turn off my music here.
It's not?
Alright, let's go.
Using screen? That's one way.
Alright, so last things. I Tuesday once a week, Tuesday evenings, 10 after 8. Get the notifications, follow, subscribe, all that sort of stuff. I will see you next week. Take care.
I want my old raid music back. This is loud. Did anybody think
That's
that
great.
was insanely loud, or was that just...